Hello students, welcome. Today, lesson 12, form 2, topic 2, we are going to see halogens, the group 7 elements. Remember the chemistry of chemical families, pattern and properties. We said we are going to discuss 4 families. The first family is alkali metal, the second is alkaline earth metal, the third is halogens, and the fourth is the noble gases. So what are halogens? We said halogens are group 7 elements in the periodic table. So the word halogen is derived from the Greek word halo, meaning salt, and gene, meaning producer. Therefore, if we combine these two, we are going to say halogen, thus means salt producer. So, what are the members of halogens? We are saying members of halogens include fluorine, chlorine, bromine, iodine, and also astatine. So therefore, we are going to say next, the electron arrangements of the first 4 members of halogens is as follows. We start with fluorine with electronic configuration of 2,7, chlorine with electronic configuration of 2,8,7. Then we are having bromine with electronic configuration of 2,8,18,7. Then we have lastly iodine with electronic configuration or arrangement of 2,8,18,18,7. So bromine and iodine are not in the first member of the first 20 members of the periodic table. So therefore, when we are writing the electronic configuration, we are going to put the third energy level and the fourth energy level occupied a maximum of 18 electrons. So that's why we are writing 2, 8, 18, 18, then 7. So we're saying, what do members of halogens have in common? Next, we're saying members of halogens have 7 electrons in their outermost energy level, hence have similar chemical properties. If you check the last energy level or the outermost energy level occupied by 7 electrons, all of them, all members of halogens. So that's what they are common in. So next we are going to go to gradation in the size of atom and ion of halogens. We are using this table. We're having the halogen, that's fluorine, chlorine, bromine, iodine, their chemical symbol. The chemical symbol of fluorine is F, the chemical symbol of chlorine is Cl, the chemical symbol of bromine is Br, the chemical symbol for iodine is I. Then we have the atomic number. Fluorine is number 9, it's having an atomic number of 9, chlorine atomic number of 17, bromine atomic number of 35, iodine atomic number of 53. Then we have atomic radius, and we have also ionic radius. And this atomic and ionic radius are measured using nanometer, nm. So if we check the atomic radius of the halogens, it's going to increase down the group. Even the ionic radius is increasing down the group, as you can see. And if we compare the atomic and the ionic radii is smaller because we are having 0.064 here in the side of fluorine atom. Then if we check the fluorine ion, we're having 0.136, showing that ionic radius is larger or bigger than the atomic radius. So let's try to see the first. We're saying the atomic radii and ionic radii of halogens increases down the group. Why? Why are they increasing down the group? This is due to the increase in the number of occupied energy levels. That's very correct, because when you check fluorine is having 2 occupied energy levels here. When you check chlorine, it's having 3 occupied energy levels. When you check bromine, it's having 4 occupied energy levels. When you go to iodine, it's having 5 occupied energy levels. So that means increase in the number of occupied energy levels leads to an increase in the atomic and the ionic radii of halogens. That's the first. Next, let's compare the atomic radius of 2 halogen atoms. Example, the atomic radius of chlorine is larger than that of fluorine. If we check the table that we are given here, the atomic radius of chlorine is 0.099. The one for fluorine is 0.064. That means chlorine is having a higher atomic radius than fluorine. What is the reason? So I'm saying this is because chlorine atom has more occupied energy levels than fluorine atoms. Let's see that using the electron configuration. So if you see chlorine, it's having 3 occupied energy levels, and fluorine, it's having only 2 occupied energy levels. So for this reason, chlorine is having a higher atomic radius or a higher ionic radius compared to that of fluorine, because chlorine is having more occupied energy levels. Okay, next, let's go and see comparing the atomic radius and the ionic radius of a halogen atom. So if you see this table, when we're talking about fluorine and we check the atomic radii and the ionic radii, or the atomic radius and the ionic radius of fluorine, we're having 0.064 as it is atomic radius, and the ionic radius 0.136. So that means the ionic radius is bigger than the atomic radius. If we check even chlorine, the atomic radius is 0.099, but when we check that of the ionic radii of chlorine, it is 0.181, showing that the ionic radii is bigger than the atomic radii. If you talk even bromine, it's the same, 0.114, 0.195. 0.195 is larger than this. If you go to iodine, 0.133 with the 0.216, 0.216 is bigger or larger than 0.133. So what does this show? That when we're dealing with halogens, the ionic radius is always bigger than the atomic radius. Or what we can say is the atomic radius or the atomic radii is smaller than the ionic radii. Okay, here we are saying the ionic radius of a halogen is bigger than its atomic radius. Reason? This is due to the gain of 1 electrons. Remember, these are halogens. They are having electronic configuration of 2,7 in fluorine, 2,8,7 in chlorine. So for them to become stable or to attain stability, they have to gain 1 electron rather than losing 7, because gaining 1 electron requires less energy than losing 7 electrons. So if they gain electron, that one will lead the ionic radius to be bigger than the atomic radius. So we're saying this is due to the gain of 1 electron, which results in the outermost electrons or in the outer electrons moving far, causing increase in the size of the ion. So that will be the end of our lesson today. Thank you.